Hey everybody, in this video I'll be going over another set of stoichiometry problems. They will be conversion problems once again. Now let's go ahead and get started. Glucose is a product of photosynthesis and is used by plants for cellular respiration. If a plant produces 2.5 grams of glucose, let's go ahead and underline that. How many grams of oxygen would be produced? Now, we're asked for grams of oxygen and we are given 2.5 grams of glucose. That is our starting value. From that information, we can conclude that this problem is asking us to convert from grams of glucose, which is C6H12O6, to grams of oxygen. Now I'm going to leave this box down here just so that we can refer to this while we're doing the problem. Now the first step in really solving for this problem is going to be writing out the 2.5 grams of glucose, which is C6H12O6, right? Now we're converting from grams of glucose to grams of oxygen, right? As I just said. Now the first step in really converting from grams of one substance to grams of another substance is converting from grams of what we have to moles of that substance. We have to do this because we know that we cannot convert directly from grams of glucose to grams of oxygen. We have to go through moles of these units. And let's go ahead and just see what it should look like. So if we're starting off with grams of glucose here, 6H12O6 grams of glucose, we have to convert from grams of glucose to moles of glucose first. Now for every 1 mole of glucose, how many grams of glucose do we have? This is where we use the molar mass of glucose, and the molar mass of glucose is really 180.156 grams. So for every 180.156 grams of glucose, we have 1 mole of glucose. Now that we have moles of glucose, we can convert from moles of glucose to moles of oxygen. So for every 1 mole of glucose, now I'm going to write this down here just so that you guys can really understand this too. Students often get confused when we do this mole to mole conversion. So look, for every 1 mole of glucose, which is C6H12O6, how many moles of oxygen do we have? Well, look at this number here. We have 6. So we have 6 moles of oxygen. Now let's go ahead and write that into our problem. So for every 1 mole of glucose, we have 6 moles of oxygen. Now we can convert from moles of oxygen to grams of oxygen, which is really just an easy conversion. So for every 1 mole, sorry, let me change the color here real fast. For every 1 mole of oxygen, we have how many grams of oxygen? Now we have to use again the molar mass, but this time it's not going to be the molar mass of glucose. It will be the molar mass of oxygen, which is 16.00 grams. So for every 1 mole of oxygen, again, we have 16 grams of oxygen. And so this is the setup that we have to go through. This is what you need to plug into your calculator essentially. And we need to solve for all these here. And so once you calculate all this, your final answer should be something around 1.3 grams of oxygen. This should be your final answer, 1.3 grams of oxygen. And so this is really how we solve for this problem. This is problem number 2. Let's go ahead and take a look at this one now. Methane is a fuel used for ovens, water heaters, and heating homes. How many moles of hydrogen would be in a 55.4 gram sample of methane? So we're asked for moles of hydrogen and we are provided with grams of methane, right? That's our starting value. So this problem is really going to be a conversion from grams of methane, which is CH4, to moles of hydrogen. Now I'm going to go ahead and box this down here so that we can refer to it accordingly as we're doing this problem. So if we're provided with 55.4 grams of methane, which is CH4, the first conversion that we need to do if we want to go to moles of hydrogen is going to be from grams of methane to moles of methane. Now this is because, remember, when you're converting from one substance to another, we always have to go through moles, and so that is pretty much why we have to go from grams of methane to moles of methane. Now for every 1 mole of methane, how many grams of methane do we have? And this is where you need to calculate the molar mass of methane, and your answer for the molar mass of methane should actually be 16.05 grams. Now we need to do a conversion from essentially moles of methane, which is CH4, to grams. Nope, to moles of hydrogen. Now for every 1 mole of methane, how many moles of hydrogen do we have? Now just like I did in the previous problem, for every 1 mole of CH4, we essentially have 4 moles of hydrogen. And so now that we did that, we calculated, or we actually wrote out the entire setup correctly, because we start with grams of methane and we finish with moles of hydrogen, which down here indicates that that's what we had to do. And so now that we did this, just go ahead and calculate this problem in your calculator, and your answer should actually be something around 13.8 moles of hydrogen. This is your final answer. And so this is how we do this problem. This is actually the third and final problem for this video. Let's go ahead and get started. Ammonium nitrate is a common ingredient in fertilizers. If a farmer had 350 grams of ammonium nitrate, how many nitrogen atoms would be present in the sample? So our starting value is 350 grams of ammonium nitrate, and we are asked for nitrogen atoms. So the number of nitrogen atoms present in this sample of ammonium nitrate, which is in units of grams. Now, this problem is essentially a conversion from grams of ammonium nitrate, which is NH4NH3, to atoms of nitrogen. And once again, I'm going to leave this down here to simplify understanding throughout this video. Now, we can get started. So we have 350 grams of ammonium nitrate, NH4NH3, right? Now the first conversion essentially is going to be from grams of ammonium nitrate to moles of ammonium nitrate. Now for every 1 mole of ammonium nitrate, how many grams of ammonium nitrate do we have? Now in order to know this, you need to calculate the molar mass of ammonium nitrate, and your answer should be something around 80.043 grams. And so this allows us to do this gram to mole conversion. Now the next conversion that we have to do is going to be from moles of ammonium nitrate, right? Because we have, that is now our unit, is going to be from moles of NH4NH3 to moles of nitrogen, right? Because nitrogen is the element that we are converting to nitrogen. And whenever we're converting from one substance to another, so in this case it's from ammonium nitrate to nitrogen, regardless of the units, you always have to just keep in mind that we're going to have to do a mole to mole conversion. And so that's what justifies this conversion that we will be doing here. And that's why we go through moles. So for every 1 mole of ammonium nitrate, which is NH4NH3, how many moles of nitrogen do we have? So look, we have one nitrogen here and another here. This is equals 2 moles, right? Because right here we have, this is 1 mole of nitrogen here, and this is another mole. So 1 plus 1 plus 1 equals 2, which justifies this answer now. Let's go ahead and take a look back at our problem. So for every 1 mole of ammonium nitrate, we have 2 moles of nitrogen. Now that we have moles of nitrogen, we're allowed to do a conversion from moles of nitrogen to atoms of nitrogen, right? And we can do this mole to atom conversion because for every 1 mole of an element, you have 6.022 times 10 to the power of 23 atoms of an element. And in this case, that element is nitrogen. Now, this is the complete problem setup that we have to do because our final unit is in atoms of nitrogen and our initial unit is in grams of ammonium nitrate. And if we take a look down here, that is what we had to do. Convert from grams of ammonium nitrate to atoms of nitrogen. So now that we have our full setup, plug all of these values into your calculator and calculate them accordingly. And your final answer should be 5.3 times 10 to the power of 24 atoms of nitrogen. Sorry, let me write that actually up here. 5.3 times 10 to the power of 24 atoms of nitrogen should be your final answer. And that's how you calculate this problem. So this concludes this video. It was just 3 problems. They were a little more complex than the last set of stoichiometry problems that I posted. I hope you understood this video and I hope you have a great rest of your day. Thank you for listening.